CloudDB, shaping your new normal.
Hello everyone, welcome to the 2021 APAC Groundbreakers Virtual Tour by APAC COEC. This year our event would be the biggest one ever done with 144 sessions, which includes the normal session, workshop and hands-on lab from 100 different speakers over 17 days and in 4 different languages. So remember to register on the remaining sessions and get benefit out of it. I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and our main sponsor, CloudDB. Now for today's session, we have Service Integration Made Easy with Kuma Mesh by Sven Bernhardt. So feel free to write questions at any time during the session at the chat tab, and the speaker will be answering them at the end of this session. If there are any other issues during the presentation, please feel free to contact me anytime. So now, without any more delay, I would like to leave you all with this amazing session by Sven. Over to you, Sven.
Thank you so much for the introduction. Yeah, a pleasure to speak to you about this very interesting topic. So my name is Sven Bernhardt. I'm located in Germany, in Cologne, and I'm working for Opitz Consulting, which is a German organization. And I'm working there as a chief architect in the business development area and caring about new technologies, new and modern architectures, and how to help our customers to improve their current architectural landscape, and how to bring new technologies in the new or in the existing IT system landscapes of our customers to help them with digitalization challenges and all that kind of stuff which is around today. I'm an Oracle AS director for years now, working with Oracle technologies for a long time, but also always had an open eye for interesting technologies outside of Oracle. And this is why I wanted to talk to you about Kuma Mesh today, and in general, which challenges the service mesh technology or the service mesh concept as such solves today, and how it helps to improve architectures, especially when we look into distributed modern architectures today. So, and we will jump in. So today, architectures are, if we talk about modern architectures, this means that they are usually distributed, loosely coupled, and no longer implemented in a monolithic way where you had a mixture of different layers with the UI layer, the business logic layer, and the persistency layer. And in one big ball of mud, you had multiple business capabilities that were implemented, and that were also tightly coupled with each other, as you can see here, with all the lines between the different layers and the different business capabilities, as the colors here indicated. So we have 4 business capabilities, and now when it comes to change, you need to change a certain box in a certain layer. For example, you wanted to change the business layer because due to some regulatory your rules, you have to change your logic there to comply with the respective rules. And you change your code, and then you also have to take care that not all other modules within our monolithic architecture that consume exactly that one module are also affected by this change. So the notion of this traditional monolithic software architecture is that we have one single deployment unit, we have a single execution process, we have a shared database, and the communication happens internally inside the application, right? So because we usually we deploy this application to a certain host, to a application server or something like that. So the target environment was crystal clear from the beginning. So also the IP addresses and the ports all were clear. And this changes because today in modern architectures we are breaking up monolithic applications, or also when we build new applications, we try to structure them according to business capabilities, to have the business capabilities in a self-contained manner, to have them isolated from each other, and if they have interconnections, this connections happens over clear defined API specifications, so that everyone is aware of what a certain business capability or API service is able to deliver, and what are the quality of service parameters and all that kind of stuff. As a result, you end up with multiple deployment units where each deployment unit is executed in its own execution thread or process. Maybe you have a database per service and not just a relational database, but maybe for some use cases you need NoSQL databases like document databases, key value stores, graph databases, or something like that, right? So we have to deal with the complexity of polyglot persistency, and also we have a lot of remote inter-service communication. So in our monolithic world, we have one single deployment unit, which was from operational perspective easier, and also from a communication perspective, because from a communication perspective, you just have to care that your application is reachable from the outside world. Now, in the modern software architecture, which is distributed, you have to take care that each and every service is reachable and that you can connect to it. And this is part of the service integration dilemma, right? Because I wanted to be more flexible, more agile with respect to rapidly changing requirements from the business. So I'm breaking up my monolithic applications, ending up with a bunch of interconnected services that are talking to each other over the network. And I need to handle that because the network as such needs to be seen as unreliable, because you may have network errors while communicating. You cannot be 100% sure that every package which is delivered by the network layers are reaching the goals. So the more distribution I have, the more traffic over the network I have, then the reliability of my overall infrastructure or over my overall system landscapes goes down. So this is part of this dilemma, and additionally, it is also a security issue, because also communication over the network needs to be seen as unsecure, right? Because you may have people that might potentially try to compromise your communication over the network. And a third thing where you need to really think of is the observability, because in this highly distributed architectures, if it comes to errors and you need to downtrace these errors, you need to analyze all the communication hops, and for this, you need a proper observability on a central place. So it doesn't help you if you have to go to each and every service in the local logs and search the logs and try to figure out what's going on. You need the overall picture in a central place with tools like Grafana, Prometheus, Elasticsearch for log aggregation, or Grafana Loki, and all that kind of stuff to understand how your service landscape interacts with each other and what's going on there. So, and furthermore, we are distributing our application architectures, but not only on the on-premise world, because we have nowadays a lot of cloud applications or applications running in the cloud, maybe also SaaS systems that needs to be integrated with the overall world. And in addition, we also have to deal with different platforms. We have to deal with applications that are deployed on a bare metal server. We have to deal with applications that are deployed to virtualized environments. We have to deal with containerized application workloads that might run on top of a Kubernetes cluster. And in addition, we also have to deal with function as a service kind of applications, right? So all this integration dilemma, which I showed on the slide before, is needs to be taken care of on different levels, right? Because we have different sorts of, or different level of connectivity, or different challenges on different levels of connectivity. We have to deal with different platforms and different different architectures. This is what makes this connectivity challenge really complex, because when it comes to for example on-prem to cloud communication, you have to deal with connectivity on the edge, right? On the edge of your company network to the cloud network, handle all these connectivity changes that might occur there. You might have cross-app communication challenges on-premise, in the cloud, and from cloud to on-premise. And you have a third level of connectivity, which is the in-app connectivity. So if you build up an application consisting of multiple microservices, then you also have to take care of the communication between those services that forms up a certain application, right? And then, as I said, you have to deal with different architectures. We have a mixture, because we regularly don't start on a green field. We have to deal with monolithic applications. Maybe some customers, or some companies have services, SOA style services or something like that. A lot of traction in the microservices space, also serverless we've seen, and we will see what comes next, right? So we also need to solve those connectivity issues for those types of application architectures, right? Because on the monolithic side, we just have to care about the cross-app and maybe the edge connectivity, but not so much about the in-app connectivity, because we have tightly coupled modules that are not separated by APIs, so at least not separated by remote APIs. It's all locally. Whereas in a microservice architecture, we have challenges on all those three connectivity levels. And as I said, we have to deal with different platforms. So with different cloud providers, and then with maybe also different Kubernetes providers, and VMware, bare metal, and all that kind of stuff. And if we look to the challenges that especially developers in this context need to deal with, is a lot of complexity, and it's kind of annoying because developers need to care about security in each and every service implementation. They need to care about logging. They need to care about metrics, about tracing, versioning, routing, and when it comes to app-to-app communication, we need to care about authentication, authorization. We need to care about rate limiting. And when apps are exposed to the outside world, we need, besides authentication, authorization, care about things like rate limiting, so that in case of denial of service attacks or something like that, we are able to limit the incoming traffic to our company's network, and also mechanisms like routing and caching to make it more efficient, more responsive, the applications and all that kind of stuff. And this is all developers' responsibility, and this is nothing which has to do with business requirements. It's just technical stuff, right? And when we also think of when we have all those self-contained applications, you can implement the applications with whichever technology you think is appropriate, or whichever technology you like. Might end up with a combination of, this is a Java microservice, there might be a Node.js microservice, this might be a Go microservice. And then you need to address all those challenges, so security, logging, and all that kind of stuff for different implementation languages, and see that you have similar libraries and all that kind of stuff. This is a nightmare from a maintenance and operational perspective. So we need something which speeds up development, which makes our development more efficient, because those are all infrastructure aspects as such, or at least some aspects that you might also address with infrastructure, right? And exactly for this, we can use a service mesh, because what is a service mesh? A service mesh is a dedicated infrastructure layer that is capable to address those technical capabilities like security, authentication, authorization, rate limiting, logging, and all those things. And as such, makes the service-to-service communication more reliable, secure, and observable. And key concept of a service mesh is the sidecar pattern. So what we can see here is that we have our services which are deployed to a host, to a VM, or to a Kubernetes cluster as a pod. And when we are in the service mesh world and your service is attached is attached to a service mesh, then the service mesh implementation will directly create a so-called data plane proxy, like Envoy or something like that. And then afterwards, the communication between services happens over the proxies. And those proxies are configured with the respective policies with respect to authentication, traffic permissions, and all that kind of stuff, which you before were expected to implement in your, or address in your service implementation. But now with the service mesh concept, you can simply declare those things and hand it over to the service mesh infrastructure. And the service mesh infrastructure takes care of this. And in the service mesh, you also have a centralized control plane from which you can configure, monitor, and manage your mesh or your meshes if you have more than one meshes. And ideally, a service mesh, a modern service mesh solution, is independent from the platform, from the architecture, and from the level of connectivity, not that much, because when we go back to this, where can the service mesh help you with? It can help you with cross-app connectivity challenges. It can help you with in-app connectivity challenges. And exactly with those technical capabilities, as I said, and on a edge app connectivity side, I can use things like an API gateway, because when I go outside my organization, I need to secure my services using an API gateway, because a service mesh, I can just apply a service mesh to services that I have under my control. And as I don't have clients outside of my organization under control, I cannot add them to my service mesh. So I need other concepts like API gateway. So API gateway and service mesh, to use them together is a really good idea, as you can see here, right? So with the combination of an API gateway and a service mesh, you can gain consistent insights into your service landscape from the edge to the target service at least. And you also can span your mesh over multiple availability zones within your organization, over multiple Kubernetes clusters, VMwares, and all that kind of stuff. The completely internal traffic inside is handled by the mesh and the mesh infrastructure, and everything which is attached to the mesh is from the mesh's point of view just a service. So also the API gateway is part of the mesh, and we will see that in the demo I have. So within this session, I also wanted to give you a quick intro into Kuma and how easy it is to get started with Kuma. So, and for that, I have a demo application, which is the Kuma Marketplace, as you can see here. And the Kuma Marketplace consists of a web shop backend, and behind the backend we have a Postgres database and a Redis cache. And what we are going to do in the following is that we try to secure the service communication by MTLS. Currently, there is no security applied. So each service is capable to talk to each service within my Kubernetes cluster. And I just wanted to allow in the next step that the gateway is allowed to talk to the webshop frontend. The webshop frontend is allowed to the webshop backend, and the backend is allowed to talk to Redis and Postgres. No other communication rules are allowed. So it is not allowed that the gateway directly talks to the webshop backend. It is not allowed that the webshop frontend talks directly to Postgres and all that kind of stuff. And when we have the time, I will also show how easy it is to get the respective observability set it up with Kuma Mesh. So for example, Prometheus, Grafana, Jaeger for tracing, and all that kind of thing. Okay, let's get started. This is my command line. I will make it bigger. So, and what we will do in a very first step is that we will install the mesh as such. We will do, so Kuma ships with a Kuma control command line tooling, which is the read-only command line tooling with which I am able to install the components. So what I'm doing here is I'm installing the Kuma control plane, and what happens in my Kubernetes cluster is that, as as you can see here, a Kuma system namespace is initiated, and the Kuma control plane is started. Now it's up and running, and that's it. So now the Kuma control plane is reachable within my Kubernetes cluster, and I will show it to you by port forward to this control plane, going to a local host. Here we go. So this is the Kuma control plane. So we have a basic mesh, which doesn't have any configurations with respect to MTLS, logging, metrics, tracing, or something like that. We don't have any services inside our mesh. And what we will do now is to add the proxies or the containers that we've seen from our web shop. We will add them to the mesh. As you can see here, we have the Kuma demo, and for example, this is the front-end application, and the front-end application is just one container within the pod, right? In the next step, we will annotate the respective Kubernetes namespace, the Kuma demo namespace. Oh, sorry for that. With the sidecar injection enabled. So this is everything you need to do. If you wanted to add pods from a namespace to the mesh, you just have to annotate the namespace, and you also need to delete the pods. And now what's happening is the pods are deleted, and what you can see in the next step is that it fires up new pods, but with the difference that we now have two containers within our pod. So one is the front end, and the other is the Kuma sidecar, which is an Envoy proxy, right? And if we now change back to our UI, sorry for that. Not sure what's going on here. It should show up. Okay. I'm not sure what's happening. Okay. Maybe I have a problem with my. Now we are back in action. Okay. What you can see here is that we now have 4 services inside our mesh, so we can watch them. And it's exactly so we have the app, the demo backend, the Postgres master, and the Redis master. So and those services have been added to our service mesh. Nothing happening so far because we didn't configure any policies. What we also can see is that we have a service mesh with one zone, right? So we don't have any zone CPs. This is because we are running in a standalone mode, Kuma, and Kuma is capable of running in a a multi-zone mode, but I will come to this later in the presentation. And what we now will do is that, as my application is just reachable within my Kubernetes cluster by port forwarding, I will also add an ingress controller to my Kubernetes cluster. And Kuma control is also able to install a gateway. And as Kuma is originally coming from Kong, you are able to install Kong gateway as an ingress controller for the gateway. So what we are building up is basically the combination of an API gateway and the service mesh, because we need something that is capable for handling our incoming edge traffic, the edge of our Kubernetes cluster, right? And if we go there, we can see, okay, the gateway is in place. And okay, the port forward has died. Okay, I will do the port forward in another window so it doesn't die. What we can see here is that we now have 5 data plane proxies. So as I said to you, everything is a service, and this might be a bug, I think, but we have a specific service. It's not a standard service or a standard data plane proxy. It's a gateway data plane proxy, and this means is what I've told you before. The sidecar pattern says that the complete traffic from service to service is handled by the data plane proxy, and this means the inbound and outbound traffic. And in a gateway, for a gateway, I just wanted to handle the outbound traffic, so gateway to the service, but not the incoming traffic, because the client application that calls our gateway is not part of the mesh. So the proxy should not handle the traffic that comes from which comes inbound, just should handle the outbound traffic. And this is why the API gateway or the ingress controller is declared as a gateway data plane proxy, because we are just handling the outbound proxy, the outbound traffic, sorry. So now we are fine. And in the next step, we wanted to enable the MTLS policy. Doing so means that we need to configure our mesh. And the good thing is in Kuma that everything, at least if you install the Kuma to Kubernetes, that you can consistently handle this with Kubernetes manifests. And what we will do, we will establish a local CA, which is then responsible for certificate management. There are also options to integrate the MTLS with existing CAs within your organization. But here for the demo, we will take the respective built-in. And if we do a refresh here, we can see, okay, now we have MTLS in place. Now, sorry, I also forget to add the ingress definition. So I forgot to add the ingress definition, so that we can reach our application from the outside world without port forwarding, right? And if I then go to if I look at the ingress definition, then I can see the IP address And now I can reach out to my application using the ingress. This means I come from the outside world, passing my ingress gateway and entering my mesh. Fine so far. We enabled the MTLS policy, nothing changed. This is because if you look to the Kuma Mesh configuration and we go to traffic permissions, is that by default everything is allowed. So it allows basically that every service inside the mesh is allowed to talk to all other services. But we wanted to do fine-grained control in the sense of what we did with firewalls before. If we connect applications with each other by opening explicit ports in our firewall, so that the communication between the different system components is allowed. And this is what I'm doing now is I'm deleting this traffic permission. It's gone. And if I go back to my marketplace application, I'm no longer able to reach my marketplace application. Why? Because I forbidden the communication between the services. So nothing is allowed. And now I add explicit traffic permissions, as I showed you in the slide. And this is, I can show you. So this is the traffic permissions. So I define the rules that the gateway is allowed to talk to the front end application. The front end is allowed to talk to the back end. The back end is allowed to talk to Postgres, and the back end is also allowed to talk to Redis. And I'm now apply this rule set, and afterwards I should be able to reach my application again. So this is, so we added security to the application, right? By defining the secured communication between the services and by defining the rules, which service is allowed to talk to which other services. And nothing else is allowed now. And within the Kuma control plane, we can also see the different permissions we defined. We can also see the YAML. We can also copy it and then paste it to the command line. So important thing, the Kuma control UI is read-only. You cannot change the configuration using the UI. You need to really use your CLI to configure the mesh. It's just read-only here at this point. Yeah, and this is everything I wanted to, or which I'm able to show. I will try to show you another point, because from the backend service, we have more than one version of this service. This is a scenario, for example, if you wanted to play around with more sophisticated deployment strategies like canary deployment, A/B testing, and all that kind of stuff. What we've done is that we scaled two other pods from the backend, and as you've seen, it changes. So we have the regular pod, and we have the version 1 and the version 2, and then we have different marketing campaigns here. So we have different articles that are in sale and not in sale. So this is the indicator that that the traffic goes to different backend pods. So going back to the command line, can show you we have now 3 different versions of our backend. And by default, Kubernetes services do traffic routing by round robin. And by using the mesh, we can control that. All right. I will apply the traffic route policy. Why does it not exist? Sorry for that. The traffic route, it was the wrong file name. And if we look through this, you can see that after applying this, 70% should go to the original backend service version 0. Then 20% should go to version 1, and 10% should go to version 2, right? And if we look back to our browser, then we see that most of the time we have the version 1, the old one, and in a few cases we also have the version 1. So with respect to the time, I will jump right back into the presentation. So just to give you an idea of the simplicity and power that Kuma provides. So I built this demo using the Oracle Container Engine for Kubernetes, OKE. So everything is deployed to the Oracle Cloud. Kuma Mesh, as I said, is completely Envoy based and comes also with the notion of a distributed control plane. As we've seen, we had a standalone deployment. So this one here. So we have a central standalone Kuma control plane, but I can also set up a more complex scenario, multi-zone, where I can also span my mesh from on-premise over multiple cloud providers, multiple Kubernetes clusters, where I also can scale my mesh, because I'm working with a global control plane, and in each zone I have a remote control plane, and this remote control plane within a zone is managing all the control, all the data plane proxies. So not the global control plane is managing all the data plane proxies, but the remote ones, and the global one control plane is just controlling and managing the remote control planes. So it's a very flexible and powerful deployment pattern. And by the way, the communication between the different zones happens over ingress. So obviously, cloud native becomes more and more important. And I also believe with our current landscapes that currently I've seen a lot of hybrid scenarios. We will see more sophisticated hybrid and multi-cloud architectures in the future. And this is the latest point where service mesh should be really considered to make application connectivity more reliable, right? And the benefits from service mesh is that we also increase developers' productivity, because all the infrastructure requirements like security, like tracing, logging, and all that kind of stuff can be externalized into the mesh and declared by the developer, no longer implemented in each and every service. So it's much more easier. You can also implement part of self-service network management by defining traffic permissions. So the way how we connect applications with each other changes. We don't need a network admin directly. And we make, as I said, connectivity more reliable. We are able to establish zero trust security, service discovery, and observability. So, as I said, we have service mesh tackles basic service integration challenges on different levels, as we've seen. So the connectivity level, the architecture, and on the platform level. And Kuma, as such, is really agnostic, because you can install it to Kubernetes. You can install it on VM or on VMs or on bare metal, and also you can also add just normal VM-based applications into your mesh. So you can use Kuma to really quick start in the cloud native world into Kubernetes, and also integrate your existing landscape, which might be mainly VMware based. So with this, I wanted to close, and happy to take any questions. If there shouldn't be any questions, I also already uploaded the slides to SlideShare. I've tweeted about this. And if you have any questions, don't hesitate to reach out to me. Thank you very much.
Yeah. Thank you, Sven, for the nice presentation. And it's a very good knowledge sharing. So I think there is no questions as of now in the chat. We can
Okay.
wind up this session. So thank you everyone for your participation today, and please do not forget to register for other sessions in the conference. Please enjoy the rest of the conference. Thank you very much.
Thank you. Bye.
Bye.
CloudDB, shaping your new normal.